Hello friends, welcome back to my YouTube channel Rafeeq Engineering Drawing. In this video we will see the development of surfaces problem number 2. Okay, so here what question says, we will see a circle of diameter 30 mm and axis 50 mm long is resting by its base on HP. The position of the solid they have given along with the dimensions. Next, it is cut by a section plane inclined at 30° to HP passing through the top right corner of the cylinder. The cylinder is drilled by a hole of 20 mm diameter such that center of hole coincide with the axis of the cylinder and at a height of 30 mm from the base. So I'll explain you one by one everything. So here what I have done is I have drawn cylinder of diameter 30 mm and axis 50 mm long. Okay, here I have taken it into 12 equal parts so that problem will be very difficult if you go with 8 equal parts. In the previous problem we have solved the same problem of cylinder having same dimensions, but problem was different, but dimensions of the cylinder are same. There I have shown you how to draw cylinder, and 8 parts, how to do 8 parts, that also I have explained you. Here I have done, then I have started the video to save the time. So here only difference is I have made 12 parts, so each part is 30 60 like that, 30 degree differences. You'll be getting the remaining all 12 equal parts. So let us proceed. So circle of 30 mm diameter, here 30 mm we have taken, axis 50 mm we have taken, its base is on HP, that's why front view is here, top view from the top it is looking like a circle. Till here it is over. Here it is cut by section plane inclined at 30° to HP and passing through the top right corner of the cylinder. So top right corner of the cylinder means this point G. At this point the cutting plane should pass like this at an angle of, with respect to horizontal plane, 30°. We cannot take 30° like this from this point. If you take 30° like this, it will go like this in this manner. So here there is nothing to cut the object, it will not cut the section plane to the object, it will go in the air. So we have to take 30° in this direction so that it will cut the cylinder. So 30° you can take the protractor and mark. Already I have marked one point, so at that point I will take 30°. So this is a 30° passing through the top right corner. So this is your cutting plane followed by x dash, this x dash I'll make it little darker one so that it will be visible for you. Actually this to be drawn with thin line, so thin lines will not come properly in the video, so that is why I'm making it little darker one. So this is the section plane which is cutting at. Here you show the angle 30°. You can mark here also outside, doesn't matter, anywhere you can do it. So 30° we have taken. Till here we have completed now. 30° to HP passing through the top right corner, this top right corner of the cylinder. So till here the question is over. Now let us concentrate from here what they are telling. The cylinder is drilled by a hole of 20 mm diameter such that center of hole, so this cylinder is having a hole of 30 mm, sorry, a hole of 20 mm diameter such that center of hole coincide with the axis of the cylinder at a height of 30 mm above the base. So above the base means here in front of VP, or below the base means here somewhere. So that knowledge you will be having in projections of solid, that we will not discuss all those things basics. So just see here and understand. They're telling 20 mm hole where at a height of 30 mm from the base. So this is the base. From here 30 mm, if you measure, it will come somewhere here, 10 20 30. Got it? So here we will try to make a hole. What we will do, we will take 20 mm hole, but not at 30 mm, we will take it at 20 millimeter. Why? Because If you take it 30 mm, then it will go and coincide with the cutting plane. The problem can be solved, but it will look very messy. Then we don't, we have to concentrate more for that. So here, this is the hole of 20 mm diameter. You can see here that I will take and keep it here. This is a center. You have to align perfectly top, bottom, right and left. So here comes the hole, which is at a height of 20 millimeter from the base, and hole diameter is also 20. This hole size is 20, and the center of hole is 20 mm from the base. So 20, I have kept the dimensions. Now we have completed question up to this point. What we need to do, draw the development of the surface. So if you cut this cylinder like this and remove this upper part, this piece, and here if you drill a hole inside that having a diameter 20, these dimensions I will do it later on, or not required. This whole diameter, how much it is here to here, you know, which is 20 is the diameter, and this height is this one 20. Earlier it was 30, I have changed so that it will be easy for us to solve this. Now we will go with the dimensions of this cylinder. How much cylinder diameter? 30 mm. So circumference L equal to pi into d. So is it visible? I hope yes. Pi into d is the circumference. Pi into d value is 30 mm diameter. So which comes approximate 94. I have calculated earlier 94. In the previous problem also same dimensions I have used, 94.24 it will come. So approximate we will take 94 or 95, 94, you can take anything. So here you can just project this. Later I'll make it dark. First I have to locate from where to where the 94 is. Even thin lines is also quite visible. So from here we will start. This is 9 means 90, 94 means just before 95. We will stop here at the 95. So here comes the sheet of the cylinder. This is without cutting. So after cutting this cutting plane and this drilling of this hole, how the sheet looks like, that we have to see. So here how many parts we did? We have done it in 12 equal parts, A to L. So here this length from here to here, this periphery or circumference length, which is 94 mm from here to here, we have to divide it in 12 number of equal parts. In the same previous problem also same procedure we did, but there we have taken 8 equal parts. Here we will take 12 equal parts. So this 12 equal parts I'll do by acute angle method. In the previous problem I have explained how to divide this. Here also I'll tell you briefly. So take any angle less than 90 degree. This is preferably 30, 45 like that. Just draw a thin line. Why? Because 94 is the length, we need 12 parts. So exact fraction will not come. The answer will come in decimal. So we don't want approximate answer. So we will be going with exact. Here this length you can divide it in 1 or 10 mm, or any distance you can take. Whatever you are taking, that should be uniform throughout the 12 parts. Here how many we have done? 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 10th, 11th, this is 12th. So this line I have divided in 12 equal parts. The gap between 2 points may be anything, but whatever gap you are taking, that you should maintain throughout the constant. 12 pieces you have to do of any length at any angle, whatever you have taken. Last point of this line you have to join with the end of this development or end of the above line. So last point or last piece of this, here we will connect. Here you have to be quite accurate. Then join with the thin lines. Now parallel to this, we have tightened this one. Your drafter have tightened parallel to this line. What you have joined, you have to move from remaining all the points parallel to this line. From all other points you have to move like this. So let us see quickly. You can also watch the playlist what I have kept on the development of surfaces. This is the third video in that playlist. First one is related to introduction, second one is the first problem, second video, and this is the third video in which we are discussing the problem number 2. So here 12 parts, first starting with the point A. This is point B, C, D, E, H, I, J, small j, K, L, and after L again first point. This is A. This first and last point should be same. Why? Because if you roll the sheet, this is one point. After that, here and here are the point A. It will connect like this here. So from here it is opening. So this point and this point are point A here. Like that, it is opened. So dimensions you can do for this, or you do it later on. Okay, let us do right now only here above. I will do where you can do it. So this is equal to your L, which is 94. So here you have to draw thin continuous line from each point. 12 points, 12 vertical lines you have to draw. So cylinder is having plane surface, but why this line? Because on the plane surface we cannot have points. So to construct points and to make a contour of the or locus of a curve, we need this 12 parts. Okay, so this 12 parts should be exactly equi-spaced. Here little 1 mm or half mm here and there it happens, but you should be very accurate. With the help of mini drafter, it is very easy to achieve. Now what I will do, first I will transfer this section plane. So section plane first wherever is meeting with the first generator A dash here. So here you name it as point P1. Second is point P2, P3. This is P4, P5, P6, and this corner is P7. Backside also it will go after P7. Here is a single point. In bracket P6 we have P8. In bracket P5 we have P9. Like that till here P2, 2 points will come. It's better I'll write P9. After that P10, P11, P2 bracket P12. P1 and P7 will be single points. I hope you can see this. This is very small and in light color I have written. You can pause and zoom it. Not an issue if it is not visible, no need to worry. Wherever this first point intersects with the first generator, this cutting plane, you see this point P1 only. So you transfer this here. The point P1 is at generator A dash. So here A we have taken point P1. This point P1 you can also transfer here at this end. You can take thin line and here. This is point P1 because this is A generator. This is also A generator. So this is also point P1. Next point P2 is here on the second generator. This is second generator going from B and L, so which is here somewhere. Cutting plane and this second generator B dash, what it is coming, you have to take that. This point 2 you have to take on this second generator B, and from here this one, last but one. So this is P1, this is your P2, this is P1, and this is your P12. This is 12, 1, 2. Next P3 you have to take. P3 will be on the third generator. Generator C will be on P3. See this third generator C, and here it is P3. So P3 projector and C generator will come here P3. In the same manner, you have to take P3 is also lies on K generator. Here you can see C and K. So on K you can mark P12, P11. Here also you can see P11 in the bracket I have written below the P3. Like that, other points also you have to continue. This is on D, P4, and this is here P10. Next comes this point, generate from the generator E dash, which is here P5, and here P9. P9 is on I and E. One is I, one is E, another is I generator. Next we have point P6, which is on F generator, F and H. So this point we will take here, and this is generator F, P6, and here generator H. So this is P8, and this apex point here, whatever point you are getting, point G, is this one, P7, 8, 9, 10. This continues like that. So in the previous video I have shown you the curvature. First the curve will be in this pattern, then curve will bend in this pattern. So according to that, here also you can follow this. So here goes the curvature of the curve. Freehand smooth curve, you have to join all the points what you have marked here. So this is done, we have related to section plane. Now we have to go for this circle, which is here at the bottom side. So for this, what you need to do, again small work you have to do. See this circle, wherever intersecting with this generator means this generator C, K, here it is intersecting one point, here it is intersecting one point, here also it is intersecting at the generators E generator and I generator here. Alright, so these things we will project here. 1, 2, 3, 4. 4 points we have to project. This 5, 6 will be overlap with this 2. See here. First I'll project throughout. And of course center also you have to project. Now see very carefully here, so many curves have came. Very light line I have taken, but I will show you with this. First generator we will take from here, these 2 points, thin lines what I have taken. Further I will make it dark for you. If 1 or 2 points, if you understood how to transfer, all other points you can transfer very easily. Okay. So these are the 2 lines I have further make it dark. 2 points and these 2 points, 4 points will be covered with this 2 lines. So this point is on generator C and K. So this line, wherever it is going on generator C and K, you have to put a point. Generator C, here 2 points. Actually this point you should not make big encircle in the exam or on the drawing sheet. And another K. Where is K? Here is the K. Here 2 holes, like elliptical shape, 2 holes will come. Why? Because this circle is nothing but a hole on the cylinder. If you have a cylinder like this, so if you put a hole, so it will appear at this surface as well as another surface back side. Example I will show you with this paper. So if you have a cylinder like this, and if you have kept a hole here, so this hole will appear here as well as it will come out here back side. So 2 holes we are getting, one is this, another is back side. So if you open the if you stretch the sheet, so 1 hole will appear here, another hole will appear here. So these 2 points we have marked here. Remaining this bottom and top points we will mark. This is on the generator D and J. So this top line, again I'll make it further dark for easy visualization. So this line, what you can see, this is on generator D and J. So generator D and this top point of the circle, and this generator G gives you this point, and here J generator and this top line here. Then bottom point is coming somewhere here at the same generator D and at the same generator J. So this part we have completed like this. So remaining curve we have to complete. Let us see quickly. Height wise maximum we have gone. So another curve will be very symmetric. It will go from this point. Okay. 1, 2, another will be 1 here. Now you have to see very carefully. This point you have to transfer here on this side. Got it? And this point you have to transfer here. Any one point is also okay. So now what to do with this? This point is intersecting somewhere here from I and in between J. In between I and J, that point distance you have to take with the compass as a radius. This is very small radius, but here you measure this distance, and from the I you can mark. This is the ith generator. From here, this distance you have to take. See, a small gap in between I and this point, right? That distance is here. You can mark like this. So I'm putting approximate distances, or here also you can see. You take K to this point generator where it is coming, this projector and point K, or L and this projector you can take. The meaning is same. So that approximate distance I am taking, and from here I am marking this gap. Or if you are measuring H2I, then from this continues up to this point, right? In between B and C. This projector of this circle is intersecting here, this end, in between B and C. So from B to C, this point is there. So from B to C, this point is here. If you are measuring this distance from B to this point, what it is intersecting, coming and intersecting here, so that distance is this one from B, like this. Or if you are measuring from C, then this is from C, this one. From B is this. So I'll join with this. So in very easy and very in detail I have explained you. If you have any doubts, please watch the video once again, and further if you have any doubts, please keep it in the comment box. Thanks for watching everyone. And here comes the final diagram that I'll make it with the dark lines. So here if I make with the sketch pen, again these points will not be visible. This curves also you have to make it dark in the diagram. Okay. Thanks for watching everyone. Please like, subscribe and share my channel.